You've probably heard about the AI explosion, right? Well, at the very center of it all is one person whose decisions are pretty much shaping our entire future, Jensen Huang, the CEO of NVIDIA. And his company didn't just get lucky, no, they led a revolution in how computers actually work. And if you want to understand where we're all headed, you've got to understand that revolution.
And this whole thing, it really boils down to that one quote. It all starts with a core belief, a massive bet that a totally different way of computing was even possible. It's a journey that doesn't start with AI, but with something way more fun, video games. But trust me, it leads to a wild vision for robotics and a future that looks very, very different from today.
All right, let's jump in the time machine and head back to the 1990s. Video game developers had this huge, amazing dream to create these immersive, photorealistic 3D worlds that you could just get lost in. But they slammed right into a wall. The incredible amount of math it took to render all the light and shadows and textures in real time was just too much for the computers back then. Their ambition was literally outpacing their hardware.
So to really get the problem, you have to understand how computers used to work. They relied on CPUs, or central processing units. Now think of a CPU as a single, highly skilled robot that solves problems one at a time. That's sequential processing. But graphics, that's a whole different beast. You need to do millions of simple calculations all at once. So NVIDIA imagined a new approach, the GPU, or graphics processing unit. The best analogy I've ever heard comes from the Mythbusters. Instead of one robot shooting paintballs one by one, imagine a giant robot that shoots thousands of them at the exact same time. That's parallel processing.
So this is the crucial insight NVIDIA was founded on. They realized that in most software, a tiny fraction of the code, like 10%, is doing almost all of the heavy lifting. We're talking 99% of the work. And here's the key. That work could be done in parallel. So they reasoned that the perfect computer needed to be a master of both, sequential processing for the complicated instructions and parallel processing for those massive, repetitive tasks. So with the GPU, the gaming problem was solved. But Jensen Huang and his team pretty quickly realized they had built something far, far more powerful. The next big question was how to unlock that power for everyone else. They were smart. They started with video games because it was a massive potential market, and that created this powerful flywheel effect. First, the huge gaming market gave them a massive R&D budget. Second, that budget fueled incredible new technological breakthroughs. And this new tech, in turn, attracted an even bigger market of scientists and researchers, creating this virtuous cycle that just kept spinning faster and faster, propelling NVIDIA to where it is today. And that flywheel enabled something truly extraordinary. People started calling the GPU a time machine. Why? Because it literally let them see the future sooner. A quantum chemist once told Jensen that with this technology, he could now do his life's work in his own lifetime. I mean, just think about that. Scientific discovery was being accelerated at an unbelievable rate. But of course, there was a catch. To use this time machine, scientists had to perform these incredibly complicated workarounds. They literally had to disguise their scientific models, whether it was for medical imaging or molecular simulations, as 3D graphics problems, just to trick the GPU into processing them. It was powerful, yeah, but it was not accessible at all. And this is where NVIDIA made one of its biggest and most optimistic bets ever. They created CUDA. CUDA is a programming platform that basically gave developers a direct key to the GPU's parallel processing engine. No more tricks required. It was a massive investment based on a simple, powerful idea. If you build it, the innovators will come. And you know what? They came. That single decision to create CUDA set the stage for the next great technological leap, one that would spark the modern era of artificial intelligence. The year is 2012. All the pieces are in place, and the world of computing is about to have its own Big Bang moment. So there was this well-known competition to see which computer system could best recognize images. And a program named AlexNet didn't just win, it completely obliterated the competition. Its accuracy was so much higher than anything that had ever come before that it just shocked the entire field. It was a signal that something profound had changed. So what was AlexNet's secret? It was a fundamentally new way of computing. See, instead of being programmed with step-by-step instructions, its creators used a neural network, a kind of digital brain, and trained it by showing it a massive number of examples. And the engine that made this training possible at such a huge scale? You got it. NVIDIA GPUs, unlocked by CUDA. This right here was the payoff for NVIDIA's decade-long bet. Jensen's philosophy is simple. While the cynics say if you build it, they might not come, the optimist knows if you don't build it, they can't come. They built CUDA and the AI researchers came, kicking off the revolution that we're all living through right now. So that brings us to today, and to Jensen's vision for what's next. Having reinvented computing for the digital world, the next frontier is the physical one, building the next generation of robots. The problem with training robots has always been the real world itself. I mean, teaching a robot through trial and error is incredibly slow. It causes a ton of wear and tear, and in many cases, like with a self-driving car, it's just plain dangerous. You simply can't get enough data fast enough.
So NVIDIA is building two key tools to solve this. The first is called Cosmos. Think of it like ChatGPT, but for the physical world. It's a foundation model that's been trained on physics, so it has a basic common sense about how things work. Gravity, friction, inertia, cause and effect.
But an AI with common sense can still hallucinate. It needs to be grounded in reality. That's where Omniverse comes in, an incredibly realistic virtual world that simulates physics perfectly. A really good way to think about it is this. If Cosmos is the generative AI, Omniverse is the grounding context. Kind of like a PDF you give to ChatGPT to make sure its answers are based on facts. In this case, the facts are the laws of physics.
By training robots in this virtual world, we can run millions of simulations in a fraction of the time, which leads to this really bold prediction from Jensen. From self-driving cars and autonomous warehouses to the humanoid robots of our sci-fi dreams, he believes this new training method means a robotic future isn't just possible, it's right around the corner.
Okay, so a world filled with GPUs, AI, and robots. What does this all actually mean for us? For our jobs, our lives, and our potential.
The common fear is that AI will make humans obsolete, but Jensen has a different perspective. He's surrounded every single day by thousands of people who are super intelligent in their specific fields, way better than he is. Does that make him useless? Nope. He says it gives him the confidence to tackle bigger, more ambitious things, and AI, in this view, does the same for all of us. So how do we get ready for this future? His advice is pretty straightforward. First, learn how to prompt AI. It's a skill, just like asking good questions. Second, constantly ask how AI can do your job better, no matter what your profession is. And finally, think of AI as your own personal tutor, ready to help you learn anything.
And that really is the ultimate takeaway. For decades, access to knowledge and skills had barriers. Now, a lot of those barriers are just falling away. We've been given a tool that can accelerate our own learning and our own abilities. So the real question this technology leaves us with is a personal one. What are you going to do with it?